Okay, so we're starting again. My name is Boris, and I'm part of the Unchained team. I'm very glad that the Grin crew has joined us for this evening, and to give a presentation on some of the most unusual projects I've seen so far. Personally, I've seen in the blockchain world, and that's got to say something, because what we're going to talk about here is sort of, as I said, the wild side of crypto things, because it's cutting, bleeding edge technology, and it also has this very specific culture to it. It's kind of the cypherpunk culture. There's no pre-mining. We're going to hear a bit about that, and there's not going to be an ICO. And people are just mad about implementing one of the most unusual cryptography I've seen so far. And also, it's one of the very few projects that has a strong narrative to it. And we should not underestimate that, because apart from Satoshi Nakamoto, who's like a myth, Doge is less like a myth, and well, Lord Voldemort, whom we're going to hear about, it's going to be a story to tell. So let's see what we hear about this project. Thank you very much. The floor is yours.
Hello, everybody. So my name is Ivan. In my daily life, I work as a software engineer, but after work, I sometimes do Grin. I would say that majority of people actually doing probably the same, because Grin has no company behind. It has no legal entities, nothing. It's pretty much GitHub and Git around it. So before we start, I would introduce the Mimblewimble. So where it comes from, it's a Tyne spell from Harry Potter. And it was first introduced in 2016. So what I'm going to talk in today? First, we're going to talk about Mimblewimble itself. So what does it mean? What it actually stands for? And all this, I would say, like properties of it. So second would be Grin is implementation of Mimblewimble. So Grin is not only implementation of Mimblewimble. There is another one called Beam. And it's actually the sidechain of the Monero that we were talking before. It's a Mimblewimble. It's underneath it for confidential assets. So then we're going to move to monetary policy of Grin, because it's a bit different from like Bitcoin or probably other blockchains. Mining. So it's also have a little bit different approach for mining. So there are like two algorithms how you mine, and we're going to talk a bit later. And I will close the presentation with where is Grin and how to get involved, because it's open source, there are no money corporation behind it. It's really need more developers and like lots of people who basically can contribute to it. So we start from a short history of Mimblewimble. So the 2nd August 2016, somebody was nicknamed Tom Elvis Jedusser. I think I pronounced it correct. It's actually French Voldemort. So it's an anagram for French Voldemort. It's so through a channel to IRC in the Bitcoin named Mimblewimble, which describes how you can do confidential transactions. And it was luckily it was read by Andrew Poelstra, who got really interested in this, and he refined it a bit and created like a white paper and published it on 6 October. Then the first commit I checked in the Mimblewimble.Grin was created at 20 October 2016, but somebody names Ignatus Pavarel. So this is the youngest brother from Tale of Three Brothers, which has invisibility cloak. So currently he is a leader, like I would say, lead developer in the project. There is another one called Antioch Pavarel. This is the middle brother. We don't have the oldest brother yet, at least. So there's only 2 of them now. Yes, so let's start to what is a Mimblewimble. And for now, in the slides, could be MW. It's too long to write a Mimblewimble. So it's great that we actually had a talk before about fungibility. So like Grin persists the complete fungibility. First, there are no way of actually create a public transaction, at least so far. So privacy by default, I would say privacy mandatory. So there's no way actually to have a view key or something like that, so far at least. So what was it different about it? It scales mostly with number of users, not transactions. So we will talk about a bit later, but the whole kind of like property of Mimblewimble, the blockchain, when it's grow, you don't need to have a whole blockchain. So you actually can have just a bit to verify the whole blockchain, which apart from Bitcoin, where you actually need from the whole beginning to verify the whole chain. And third one is elliptic cryptography. It was picked by, it was originally in the Mimblewimble document, and it was picked by, first, well known and used and tried, so it actually have like a battle-tested kind of type of cryptography. And also, I wouldn't talk about this in the talk. It's a bit more deep. It's like, but the Mimblewimble use the Pedersen commitment, and it rely on elliptic cryptography properties. So that's why we picked. And this fourth one, it's pretty tricky one, and it's so if you think about a cash, like fungibility, you have like a coin and another coin. If you want to transfer some cash to your friend, you need your friend to be present, right? You cannot transfer cash to your friend, but friend is not here. So either you would do it like from hand to hand, or I don't know, I would put it like in some secure box and tell the friend the PIN code, and the friend would need to came to take it. So idea in Mimblewimble, like in Mimblewimble in Grin, is the same. So it's interactive to create a transaction. It's not online. So both of parties, like Alice and Bob, shouldn't be online, but they should interact to create a transaction. So, and there is no things like addresses at all. So there are no address in Grin. When we create a transaction, we just both know what's in there, but nobody else know, and they cannot address it anyhow. And we can start talking about confidential transaction. I would explain to an example. So Alice wants to send Anne Green to Bob. So, and we assume that Alice had some unspanned output to create a new one, basically, for Bob. So, and they need to cooperate. So she actually sends something, in Grin called slate, to Bob, and Bob sign it and send it back. So Alice now can publish it to the network. And what properties would see after this happens? So first, it's impossible to distinguish this output from others. So like basically outputs are just big numbers. Like in the block it's just big numbers. And the inputs are pretty much the same. And it's also impossible to match which input and output belongs to each one. And the last but not least, its amount also impossible to get from this because it's just the big numbers. And only the knowledge about the amount know Bob and Alice and nobody else. And it never stored in the blockchain because creation of transaction not in the blockchain. It's like you can basically use email, PGP key, Telegram, Signal, whatever you want to create a transaction, and only the result going to be published there. So second, I started talking about scalability. Why it actually doesn't require that much space. So first, it's we don't need to whole history of transaction when you have a block to verify that block doesn't add any new coins. And this is done by first bullet proofs, and the second is by property of elliptic cryptography and Pedersen commitment. Then we can verify that the actual sum is 0. And I wouldn't really talk now deep about this. If you have a question, just come by after. I would be happy to explain this. So, and node doesn't need to have all the block, like to actually verify that blockchain is valid. You need just a few of the blocks to kind of guarantee that. And more of this, like in Grin, there are no full node. There are just node and archive node. So archive node you can have if you're, you just want to have an archive. But node itself doesn't need to have a whole storage. And usually there is a, so I guess in Grin called horizon. Like you will see only the blocks before the horizon, and you don't need more. So you basically just keep the tail of the blocks, and that's enough for you. So you don't need to keep everything. Cool. So another thing is called cut through, which is awesome thing if you think so. So let's take an example. Like Alice give 10 greens to Bob. So Bob now want to give 10 greens to Carol. So usually, like in the traditional blockchain, we will have 2 transactions. But if you think, why we need to ever have Bob in the blockchain for this? So basically, after these 2 transactions happen, well, if there would be Bob or no Bob, there doesn't matter, right? So that's what happened as well in Mimblewimble. You basically just eliminate this. You don't need one. You just say, okay, Alice sent to Carol. And on a block, when you form the block, all the inputs and outputs, you just take the same on the right side and you just cancel them. So you will never have this record in the blockchain as well. And this can save, like, I think it's a space as well. And yeah, that's potentially there is so theoretically it can be done on the block level. To be honest, I don't understand how, and that's not implemented, but it's stated like in the documents. Using this one, you can actually eliminate transaction for previous block, but that's not, like, it's not done now, and probably would never be. Cool. So now it's Grin is implementation of Mimblewimble. So As I thought, there is not one, there's at least two now, the Beam, another implementation, and Grin one. It's a bit different how they develop. So Grin is completely open source, and well, it has a couple of things in it. So first, it's implemented completely in Rust, and as far as of today, I heard there are only 2 unsafe calls in the Grin code base. So second, it used bulletproofs, which was talked already in a previous talk. So fasting by default, this is what we talked before, that you don't need a whole history of blockchain to be able actually to use a node. And the third, a fourth one, it's a down the line. So down the line is something like I2P in Monero. So basically, it's provide privacy when you send something to the network, so the what you send a transaction can be untraceable to you. Sheriff queue, so there are no ICO, no founder rewards, no pre-mine, no pre-anything. So it's like you can't buy Grin. Don't people write into devs and Git are like, hey, if I give you 1 Bitcoin, how much you would give me back? There's no way to do in this one. So the mainnet going to be launched on the 15th January. And from block 1, there will be competition about miners or whatsoever. So down the line, I'm going to briefly just mention this. So it's like a network layer anonymity protocol. It's sort of this similar to Monero I2P, purpose to hide who created the transaction. If you're interested, and you probably might be, there is an amazing talk by Quentin at the GreenCon. Basically, he explained the whole thing, 40 minutes or something, of actually how that works. I'll put this slide somewhere, so they're going to be in the meetup group. So if you want to check it out later, you can just check it. Monetary policy. So Grin uses linear supply. What that means that every minute there are 16 greens go to a miner for a block reward. Actually, why 60? John Trump said because there are 60 seconds, and 60 is a nice kind of number to just you get 1 green for 1 second. It's okay, that's official answer from him. So what that means, supply is unlimited. So all the time, if in 10 years you want to still mine some green, you're able to. Apart from Bitcoin, when essentially if you want to mine something, well, you won't get much. You need to buy something. So and in green, you still can mine this. So fee proportional to number of outputs, and back proportional, so number of inputs. So and I'll explain why. And actually, what does it mean? If you have 10 inputs, and you use all of them to create 1 output, you'll pay less fee if you just used 1 of them and create 1 output. Why so? Because the one thing you still need in Grin, the whole UTXO. And the less it is, the better it is for the blockchain. So this is basically to incentivize people to use as much of inputs as possible to create outputs, and this is reflected in the formula. This is guaranteed not to be less than 0 as well, because there's some other non-relative to input outputs numbers, but yeah, so this is kind of incentive for people to keep it less and do not so it's not grow. Mining, so it's kind of different list from what I see in other cryptocurrencies. So it has 2 algorithms. So one of them is ASIC friendly, and another one ASIC resistant. So it's going to be launched when only 10% of the blocks would actually go to ASIC friendly algorithm, and this is done to prevent them somebody would just launch the massive ASICs basically and get something like 51% attack or something like that. So we start with the you need to GPU, and because we also want to make ASICs pretty expensive, it is affected on the GPU mining, so you need to have a video card for 7 gigabytes or something. So it's a 1080 Ti would work, but some others with less memory wouldn't really be beneficial because it's a memory heavy algorithm. And essentially in 2 years, it's going to be balanced to 100% go to ASIC friendly algorithm. By then, I guess community hope that the ASICs would be created already, but then there will be fair game. So there will be somebody just jump in and just have a hash rate. If you want to take more on this, there was an hour talk from creator actually of both of these algorithms, John Trump, also available on YouTube. And he explained everything how it works and actually why he chosen exactly this algorithm and so on and so forth. So where is Grin now? I didn't put too much numbers, so I get stars on GitHub and how many people in Gitter. Well, now it's testnet for launches 15 January when it could be block 1 and so on. This is it's hard to get where's open source project are. It's just how much community you have, and I don't know how much stars on GitHub you have. So get involved. There's a list. So if you know some Rust, you just go and do Rust. So if you have a design UX skills, you just go to channel code /design and Gitter. There's talks about wallets and like websites and so on. It's not really everything. It's like front-end dev, just web wallet. I think it's broken now, so it just doesn't work. It needs to be fixed. So if you're mobile dev, myself working now on the iOS Android implementation, it's also just in the early stage, so there's no way actually using Grin on a mobile. You pretty much now you need a VPS. You need your server, you need Connect, or if you want to send Grins, you probably want to actually open TCP IP port and just send them there. So I wouldn't say that it's really user-friendly so now. So know how to write documentation. Well, there are lots of places it can be improved, can be added, and so on. So if you're very smart, confidential assets is actually not ready in Grin. There's like some ideas how you can do it, but it's not there yet. So if you're very rich, we have security audit fundraising campaign, and I mean we Grin community. So because before basically launch, we want to get audited by some like well-known, I don't know, like security researcher guys. There is a campaign for 16 Bitcoins to gather that to pay. So 9 out of them already like we kind of gather from community. But if you want to help us support, so I would put in the last slide the link where you can actually find like all the Bitcoin addresses and so on. And for all the rest, there's a lobby channel in Gitter. It's very welcome. You can just say hi, what I can help for, and you will definitely find somebody to just guide you there. Yeah, and this is I guess the latest slide. So there is a VAT document. If you read it, you would understand why elliptic curve cryptography, what is a Peterson commitment about, how the blockchain cut-through works, and everything. It's like I don't know, 10 minutes read. So there is a videos from GinCon, lots of about like how down the line works, what actually state of the wallets, and also overview of the Grin and the Mimblewimble cell. Gitter isn't mentioned. There's a forum as well as a Gitter. You can actually communicate there. There's quite a lot of discussions. Security and audit fundraising campaign. It's on the link. And myself and Gitter tweet whatever. Telegram like that. Yeah, we can do that. Yeah. So this is pretty much it, I guess. Thanks.
Do you have lock times on transactions or outputs?
So it's actually, as far as I know, now they're being implemented, called TTL basically. So now the problem, like when you send money to somebody, you get locked your transaction in your local wallet, and if that didn't happen after a certain time, they need to be cancelled. So that's being implemented. So far as I know, they're not like a time to. You mean time to lock?
I mean like op CSV and op CLT.
As far as I know,
in Bitcoin there's a relative lock time, right? And there's an absolute lock time.
So
the absolute lock time is a minimum block number that the transaction has to, a maximum block number that the transaction has to be, I think, and the relative is about how many blocks has passed since you. When you spend an output, right? How many blocks? As far as I know,
no, but I can be wrong. So there are no scripts. There are nothing like you can do. There is like.
Yeah, but in Bitcoin the lock time is out. You have an end lock time field, so it's not part of the script.
As far as I remember, JSON of transaction, I don't know.
I think Grin has one of them, but not the other one.
I mined a testnet block, and there was like you can spend these coins after X.
Yeah. There's like a 10 blocks. It would say like it's immature coins. You would wait for, I guess, 10 blocks for user transaction, and I guess 1440 is like half a day something. You would wait for your Coinbase basically being spendable, as far as I remember.
But that's hard coded, and you cannot.
I think yes. So far, yeah, it's like a constant in there.
I think that's separate. You have that in Bitcoin too, right? That's Coinbase maturity.
Yeah.
In Bitcoin, it's 100 blocks, I think. Okay, but yeah, that would be interesting because it's needed for Lightning, right? Andrew Poster wrote a mailing list post about doing a replacement for HTLCs with elliptic curve cryptography, and that fits very well with
like in community, so at least in GreenCon, there are a lot of talks about confidential assets and Lightning, how to implement that, because there was a, first, atomic swaps was also not possible because there are no scripts, but Jasper did the proof of concept. We actually did atomic swap between Ethereum and Bitcoin and Green, like 2 couples of them. But they're like you need to 8 times to send back and forth the file. It's not really user friendly. So they need to be optimized because it uses Schnorr signatures. You basically need to all the time be sending these back and forth. So it's possible, usable. Well, question, but it's better than nothing, right?
Well, I mean, if the protocol is standardized.
Yeah, but so far no wallets. There are only one wallet, CLI. The CLI wallet, this is most, I guess, the maintainable one. There is a web, but the web wallet also works when you install it in the server and it's actually listened to localhost only and it's hard-coded. And it's hard-coded on purpose. So if you're installed in your DigitalOcean, you only can go there and listen it from when you connect to it. So it's pretty not that user-friendly. But what we did, for example, with iOS app, so because of Rust, so I just compile Rust to a static library and run it from iOS. So who crypto things, basically you just call its receive bindings and you're good. And this is the same code base. And the same can be done, I hope, on Android. So I haven't touched it yet. But now also a friend of us working in Trezor implementation. And hopefully that one will be possible as well.
So is January 15th a hard date, or?
It is a hard date, I guess. It's publicly available, so it should be there. I mean, it's just like a community-wise. Somebody who you don't know who decided I mean, it's hard. When we had a present on GreenCon, there was a talk because Ignatius Pavarel, nobody knows who that. He actually connects by SSH and speech to text to speech. Did a talk. So there was a Green council. So there's I don't know, up to 10 persons. They basically kind of decide on that one, I guess. So there was announced that 15 January going to be mainnet. We'll see.
So when I want to transact, both parties have to be online?
No, they don't need to be online, but they both have to be present. So if I want to transfer you money, you need touch sort of transaction. But I can put, for example, transaction, I don't know, send you an email, the file. You would be in 2 days actually take this file, you would sign it and send me back. And after I can just put this file in the node and in 10 blocks it's mined and your money there. So it's more like a cash, I guess, analogy is pretty good. You cannot just put the cash somewhere and person received it. No, person need to take it. So, or I put it in some box, but you need to take it from the box. But it doesn't mean that we both need to be online, because that would be unusable. You go into U-Bahn and it's no money.
And then I would just have a private key that I keep on my device, and I sign the initial transaction that you want.
Yeah, so it's implemented BIP32. Basically, you have a seed and you are just signing each transactions. Cool.
Okay.
Thank
great.
you.
Thank you so much.